to this video on statistics, statistical analysis. What does that mean? Well, first of all, we think about what statistics is. It's about doing three things with information. First of all, it's gathering information, getting stuff from just counting things, asking people things, filling out questionnaires, looking at lists, getting information. Secondly, the analysis is basically what can we tell from it? So what? What can we learn? So that's it's big word. Statistical analysis just says what can we learn from the information that we've got. And the last thing, which you might be familiar with, is how do we communicate that? And that's when we draw graphs, bar charts, or line graphs, or make a table, and we show other people what we've found. So the statistical analysis in the middle here, we're familiar with the idea of percentages. We might say, 20% of people surveyed would vote for this candidate, or like Iron Brew. We've got these other things, averages, range, and standard deviation. And we're going to have a look at these things mainly in the next few lessons. So let's have a look at the idea of an average. You'll know the idea, but do you really know what it means? An average is when we take a list of numbers, we call that data, and we choose one number to represent all the information. So rather than letting people know every single number, so if you ask 50 people, something like how much they earn, you don't give them all that information, you give them one number, and that would be the average. And that kind of sums up, it's a quick way of giving a rough idea of what the answer is for everybody. We often think there's only one average, but there's actually three. That's what we're going to have a look at just now. There are three different types of averages. They all do the same job in that they all try to give a representative or a typical value, but we get them in different ways. So sometimes we need to maybe choose one over the other because we think it's actually fairer to use than the other. So let's have a look at the three: mean, median, and mode. We're actually going to start with the last one first because it's actually the easiest one to think about. The mode is the most common. Think about the fact they both begin with mo. Most common is the mode, and all you need to do is think what number appears the most times. That's it. It's helpful but not essential to make sure that the list of numbers is in numerical order, otherwise you can miss something. So here's the example. Find the mode, or sometimes called the modal value, in each data set. So in A here, we've got a list of numbers that are helpfully in numerical order. We can see that there's 2 7s, there's 1 8, there's 3 12s, and there's 1 15. So we can quite easily say here that the most common value is 12. So we can write down that the mode equals 12. It's not correct to say the mode average. We don't use average with each one. We just say the mode is 12. Okay. And let's have a look at this other list here. They're all muddled up, so it's sometimes helpful to write them in order. So the smallest one is 1. If you're writing them out in order, it's sometimes helpful to write it out first, unordered, so that when you write them out in order, you can score out the ones you've used. So I've got 1. Is there a 2 here? Yep, there's 1, 2. Is there a 3? Nope. 4. Yep. 5. We've got 1 5, 2 5s, 3 5s. So 5, 5, and 5. We've got 1, 2 6s. And we've got an 8 and a 9. I'm just going to double check. Oops, no. See, I got another 9 there. I didn't score that one out. So I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers in my original list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers in my new list. Really take care and don't rush trying to reorder numbers. So we can see here that, again, we've got some doublers. We've got 2 6s, 2 9s, but we've got 3 5s. So in this list here, we can see that the mode or the modal value is 5. So that's the mode. Nice and straightforward. Sometimes that's a good average to use, but in fairness, it's not the most common one. Okay, just because you can kind of get an average value which is not really typical of all of the numbers. It just might just be luck. So the two more common ones, we've got the median here. That's quite a common average. So how do we get that? The median average is the middle number in an ordered set of data. In other words, if you were to imagine lining up a class of pupils from the smallest to the tallest, the median height would be the person who's standing right in the middle. Okay, so there's a wee catch in all of this, is that what happens when nobody's in the middle. So let's have a look at the first one, find the median of these data sets. So we've got 5 numbers here. You can quite clearly see with a small list that that's numbers in the middle. One way we can think of it is that we get to the middle by scoring out the first and the last, and then also by scoring out now the new first and the new last, until we've only got something in the middle there, so 17. So we can say here that the median equals 17. There's another way of thinking about it, and that is I quite often use an arrow, and I kind of draw an arrow underneath like that. What happens, and I try and think, well, where do I position this arrow so that there's the same number of numbers to the left and to the right? So if I put the arrow on 17, you can see that to the left of 17 there's 2 numbers, and to the right of 17 there's 2 numbers, so I'm bang on in the middle. So that's another way of thinking about it. Let's have a look at the second list here. Are they in order? Yep, that's good, they're in order. So I don't have to think about reordering, but if you have a look at, we'll use the 2 methods here. So let's first of all try and score out one end to the other. So we'll score out the first and the last, and then we've got these 2 at the ends. And if we score out these 2, you'll notice that there's nothing in the middle. So that's a wee bit of a confusion. Does that mean that there isn't a median? Well, what it means is the middle is right in between 2 numbers. It's not on a number. Okay, so I'll undo the scoring because it's not always the. Oops! Oh, hang on a minute. Leaping on. Here we go. Let's undo the. Let's just rub that out for a minute. Right, let's use the arrow format. I'm just going to nick this arrow actually. So let's have a look at thinking, where would this arrow go so that there's the same number of numbers on either side of it? If I point to the 52, there's 2 numbers to the left and 3 numbers to the right. That's obviously not balanced. If I move it up to 64, there's now 3 to the left but only 2 to the right. So just as we found scoring them out, the actual middle lies in there, in between. I can see there's 3 numbers to the left of the arrow and there's 2 numbers to the right, 3 numbers to the right. So that's perfectly balanced. But what is in the middle? Well, the median is halfway between the 2 numbers, halfway between 52 and 64. So there's a gap of 12 there. So halfway up 12 is 6. 6 add 52 is 58. So the median would be 58. Okay, another way to do it is you add them together and half it. So if the numbers are the same, if that was 52 and 52, then the median would just be 52. So if the 2 numbers on either side are the same, that's just then that number itself. So the last one here, we can see that they're not in order. So I'm just going to move this up. And again, I'm going to write them out in order first of all, because it has to be. Otherwise, we won't get the true middle. So let's think about that. The smallest number is 3. There's 2 3s. What have we got? We've got a 6. No, we've got a 5 and a 6, and then an 8, and then a 9. Oh no, I've missed out 7. You see, I wasn't very observant there. So I've got 7 and 8. 7, 8 and 9. Let's just check. 7, 8 and 9. Yep. Then I've got 10 and 12 and 13. 10, 12, 13. Nothing left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. So what's in the middle this time? Well, let's think about where the arrow goes. I'll borrow it. Here's the arrow. So let's think roughly somewhere in there, isn't it? So if it's on the 7, for instance, I've got 4 to the left, 5 to the right. Nope, and the same's going to happen with if I point it to the 8. So again, it's going to be in between. One of the ways you know is if there's an even number of numbers, the median's going to lie in between two numbers. If there's an odd number of numbers, like here there's 5, then the median's going to lie on the middle number. But if it's even, it's going to be in the gap. So in between 7 and 8 is 7.5 or 7.5. So in this case, we can write down that the median is equal to 7.5 or 7.5. Okay, so that's how you find the median number. You line them all up in order and find the middle value. Last average is the one that's the most common that people use, and that's the one that everybody thinks is the only one. So it's actually called the mean. Quite often you'll hear people just say the average is, and they actually mean the mean. In other words, you add them all up and share them back out. So, yeah, as an example here, if I've got 6, 1, 2, 3, 4, 5, 6, and 2, and 3, and 5, and 4, the idea of the mean is that, well, how would you get them all to the same level? If I borrowed one there and put that there, and I took another one there and put it there, if I took that one, do you notice that they're all the same level now? Another way of thinking of it is if I just put them all together in a bowl and then shared them back out in 5 piles, how much would be in each one? So the short answer is that we know that the answer here will be 4. How do we get that? Well, we can say that the mean, there's only one that requires a calculation. And I'd like to see the fraction. It involves adding them all up, 6 plus 2, plus 5, plus 3, plus 4. Add them all up, 8, 11, 16, 20. Divided by how many numbers are shared back out 5 times, gives you 4. So we add up all the values that we've got and we think, well, if we want to share them equally in 5 different piles, we'd have 4 in each one. So that's how we find the mean. You don't have to have an ordered list. This is the only one that it doesn't really matter. So again, and you might need a calculator, the mean here is, we've got a fraction. There's 6 numbers, so the bottom number is going to be 6. If you add these 6 numbers together, we get 13, add 16, add 17, add 50, add 30, add 28, gives me 154. And if you divide 154 by 6, we end up with 25.6667, according to my calculator, 25.666, and so on. So I would round that to something suitable. I'm just going to do it to 1 decimal place. But you might round it to something else depending on the information you've got. Okay, so that's the average. Again, we don't call it the mean average, we just call it the mean. Okay, 3 different ways to work out the same thing. And lastly, the range, just to throw this in, this is not an average. It's a really helpful tool which helps to describe how spread out the numbers are. Okay, so it shows you the gap between the smallest and largest number. The bigger the range, it means the more spread out the numbers are. So in question A here, we can see the biggest number is 6, the smallest number is 2, and so we can say that the range, it's always good to write them out, don't just do it in your head. Largest minus the smallest, the range is 4. That's quite a small number. It says that the numbers are quite close together. If you've got this one here, the biggest number is 50, the smallest is 13, so we can say that the range is equal to 50 minus 13, which is, what's that, 37, which is quite a big number. It shows indeed that the numbers are quite spread out. So have a practice at them. Hopefully that's a bit helpful, and we'll go on and learn more about that later on.